Let's kick off this lesson by taking a very close look at a pupil that is reacting to changes in light by dilating to larger and smaller sizes. Similarly, in geometry, a dilation is a stretch or a shrink of an image. By stretch, we mean to make larger, and by shrink, we mean to make smaller. Whether it's someone's pupil, a geometric figure, or any image, a stretch just means to make a larger proportional image of the original image, and a shrink means to make a smaller proportional image of the original image. Note that unlike other transformations, a dilation is not a change in orientation, and a dilation is also not a change in shape. When dilating an image with a scale factor of k, we use the following capital D notation. Dilating a point P with coordinates x, y to the new image P prime involves multiplying the scale factor by both the x and y coordinates. The new x coordinate will be the product of the scale factor and x. The new y will be the product of the scale factor and y. Before we begin any examples, let's try to conceptualize what a scale factor actually is. K represents a value, and when k is 1, the image is unchanged. When k is greater than 1, we are stretching out or making the image larger, in this case 1.5 times as large. The larger that k is, the larger the image is being stretched out to be. In this case, 2 times as large. So when our scale factor k is greater than 1, the image is stretched to a larger size. Remember that a scale factor of 1 leaves the image unchanged and brings it back to its original size. However, if the scale factor k is less than 1, we are making the image smaller, in this case, half as large as the original. Now we can continue to shrink this figure down in size until we reach 0. Now, since a scale factor of 0 would completely eliminate the figure, we can say that a scale factor of k that is greater than 0 but less than 1, in between 0 and 1, would represent a shrink where the figure is made smaller in size. Note that this restriction only applies when the scale factor is less than 1. There is no restriction on stretching out a figure to a larger size. For our first example, we are going to perform a dilation on triangle OMG. Notice that the scale factor k is 2, which is greater than 1, so this figure is going to be stretched out to a larger size. We'll start by writing down the coordinates of the vertices of triangle OMG, and then applying that scale factor of 2 to each x and y coordinate. In this case, we're multiplying all of them by 2. Now, -4 times 2 is equal to -8. 1 times 2 is just 2. 3 times 2 is equal to +6. 2 times 2 is equal to 4. Again, 2 times 2 is equal to 4. And finally, -2 times 2 is equal to -4. We can go ahead and plot those new points, O prime, M prime, and G prime, and construct the image of the figure that is twice as large as the pre-image. Now let's visualize how when the scale factor is greater than 1, the image is stretched out to a larger size. For our second example, we are going to perform a dilation on a 4-sided figure. The scale factor for this figure is 1/3, and since 1/3 is less than 1, we know that the image is going to be shrunk down to 1/3 the size. We can start by writing down the coordinates of the vertices of M, A, S, and H. Then we'll take the scale factor of 1/3 and multiply it by the x and y value in each coordinate. We'll start with -9 times 1/3, which equals -3. 3 times 1/3 equals 1. And we will continue this process of multiplying each x and y coordinate value by 1/3 to find the coordinates of A prime, S prime, and H prime. We can now plot those new points and construct M prime, A prime, S prime, H prime, the image of the original figure after the dilation. So now we can better understand that when the scale factor k is greater than 0 but less than 1, the image is shrunk down to a smaller size. Here are some final words on dilations. Dilations result in an image that is larger or smaller in size than the pre-image. When the scale factor of a dilation k is greater than 1, the image is stretched out to a larger size. When the scale factor k is less than 1 but greater than 0, the image is shrunk down to a smaller size.
Thanks a lot.